Okay, everyone. So the first in-class online video is going to be Handout 2F. And this is one that I would have normally done in class, but since I'm quarantined, I can't do it. So I'm going to just go over it now. And hopefully you are looking on D2L to find it. Of course, if you are watching me, then you found it. So good job. All right. So Handout 2F is just talking about the fields of chemistry. And there are two major fields of chemistry, inorganic chemistry and organic chemistry. Inorganic chemistry is chemicals that do not contain carbon. So, our body is made up of some inorganic molecules, things like water, oxygen, salts, acids, bases. These are all examples of molecules that don't have any carbon. And they do make up a percentage of our body, although not very much, with the exception of water. So water is the most common molecule in our body. We're made up of about 60% water. And I know a lot of you might think that's a little bit low. You may have heard some false information about how we are higher water. Some people think that we are about 77% water because they've heard this mentioned that we have the same amount of water as the percentage of ocean on the earth. Well, that's not right. And then I have seen like a stupid meme that said something like, well, I'm 90% water and a cucumber's 90% water, so I must be just like a cucumber. That's wrong too. I don't know where they get their information, but we are about 60% water. Water is used for many different processes in our body. It can be a solvent. It can be a stabilizer. It is a molecule that can protect us. And it's a site where most of our chemical reactions actually occur. So this is why water is so important to us. Another molecule that's inorganic is oxygen. And we're going to talk about this a little bit later in the class, but oxygen's needed for the production of energy. We also will have some salt in our body, and salts are going to form ions. And we've talked about what an ion is in a previous handout. So ions are important molecules that are going to help run our body. So ions like potassium and sodium and chlorine. Then, of course, we have acids and bases. There are areas of our body that are very acidic. DNA is an acid, actually. All proteins are acids. So our body is made up of a lot of proteins. So those are acids. Remember, they're made of amino acids. Things like breast milk, urine, saliva. The female reproductive tract is very acidic, and that's mostly to guard against pathogens. And then there are areas of the male reproductive tract that are also acidic. Another example of an inorganic molecule are bases. We do have some bases in our body, like blood is slightly basic. The cerebral spinal fluid is also slightly basic. We have substances in our pancreatic juices that are there to neutralize stomach acid. And then we've got bases in our male reproductive tract to neutralize the acids in the female reproductive tract. And that's going to help little sperm survive. Now, acids, remember, on the pH scale are somewhere between 0 and 6.9. Bases are from 7.1 and above. to 14. And then neutral would be right in the middle at 7. So if you're not familiar with the pH scale, that's kind of how it lies. So if you look at anything like stomach acid is near a 1 or a 2, so it's a very acidic molecule, for example. Our body is going to generally be neutral. So we're going to be neutralizing acids and bases for the most part, and we're going to hover around the homeostatic balance of being neutral overall. Even though things like our stomach and reproductive tracts may be very acidic, our overall body is going to be rather neutral. Now, we're going to mention some things about inorganic chemistry, but our body, with the exclusion of this 60% of water, but if you were to drain all the water out of the body, our body is mostly made of organic molecules. And we're going to talk about these organic molecules in different handouts that are going to come after this one. So it says organic chemistry have carbon-containing substances. So all of these substances have carbon in them. They form these very complicated molecules that are really the biomolecules. They are the molecules of life. And so they are carbohydrates, lipids, proteins, and then, of course, our nucleic acids, DNA and RNA. So what I'd like to do is talk about each one of these separately in a different handout. And so when we go into the next several handouts, we'll just be talking about these different biomolecules a little more specifically. So we're going to start with carbohydrates, and then we're going to work our way through the 4. All right, that concludes this short little video. And look for your next handout, which would be handout 2G on carbohydrates. All right, I'll see you all soon.